multiple choice questions. This one's a bit of a weird case because I've had to crop it out and you can't actually see the question because the mark scheme would come up as well. But it should be fine anyway. It says ethanol dimerses in dilute alkaline. Ethanol dimerses in dilute alkaline solution to form compound X as shown in the following equation. The chemists studied the kinetics of the reaction at 298 Kelvin, aka 25 degrees Celsius, and then proposed the following rate equation. A three-step mechanism has been proposed for this reaction according to the following equations. Step 1, step 2, step 3. You know, the classic kind of question. State which one is the rate determining step. Explain why. Now, if we look at the rate equation, we've got CH3CHO and we've got OH minus. And now if we look at step 1 and step 2, well, step 1 and step 2 both have CH3C double bond OH. However, step 2 doesn't have OH minus by itself with lone pair of electrons. Therefore, step 1 is the RDS, rate determining step, aka the slowest step. Reason being, involves 1 CH3 CHO and 1 OH minus. Perfect. Step 1 involves ethanol and OH minus in the rate equation. Yeah, it should probably be a bit more wordy. Well, CH3 CHO and OH minus in the rate equation. Might seem common sense, but you know, you could potentially lose a mark for just not saying it in the rate equation. Second one, yeah, because that's the mark scheme for the first one I just did. Second one, complete the table of data below. Reaction between NO and H2. Notice again is that it's these two are the gaps, but it's already been done because I snipped it when it's complicated. So we're gonna have to skip part A because it's already done for us. Whereas part B is probably the harder step. I think most would agree on. Maybe the easier, depends on which you're more confident with. It says using data from experiment 1, calculate value for rate constant K and status unit. So it just tell you what the rate constant K is. K, right? So we need to rearrange it. So we get K equals rate divided by NO squared H2. Now using the data from experiment 1, we just substitute in initial rate 1.8 times by 10 to the power minus 5 divided by NO 3.0 times by 10 to the power minus 3 squared times by 1.0 times by 10 to the power minus 3. No squaring on that, and that will give me K. What I've done is rearranged it. Rate is K NO squared H2. K is rate divided by NO squared H2. And now the units. Well, first let's work out the value. 1.8 times by 10 to the power minus 5 divided by 3.0 times by 10 to the power minus 3 squared times by 1.0 times by 10 to the power minus 3 2000. K equals 2000, rate constant equals 2000. The units, okay, so the rate is obviously mol per dm minus cubed s to the power minus 1 divided by, well, we've got mol per dm minus cubed squared and we've got mol per dm minus cubed, so that's going to be mol per dm minus cubed, mol to dm minus cubed. That will cancel out and we'll be left with s to the power minus 1 over mol dm minus cubed squared. That is the same as s to the power minus 1, expand the denominator, mol to the power 2 dm to the power minus 6, but because that's the denominator we're going to do the inverse, so it's going to be mol to the power minus 2 dm to the power 6 s to the power minus 1, and that is the units. 2000, perfect. Mod to power minus 2, dm to power 6, s to power minus 1, and also showing that it's 1.8 times by 10 to power minus 5 divided by 3.0 times by 10 to power minus 3 squared times by 1.0 times by 10 to power minus 3. That's the end of multiple choice question.